Hello. Today I will be going through the steps of a projectile motion problem. Here is our example, our situation. A projectile is shot from the edge of a cliff 125 meters above the ground level with an initial speed of 105 meters per second at an angle of 37.0 degrees. This question wants you to find multiple things. One, time. Time taken by the projectile to hit point P at ground level. Point P. Next, determine the range X of the projectile as measured from the base of the cliff. C. The horizontal and the vertical components of its velocity. And D. The magnitude of the velocity. So magnitude. And lastly, the angle made by the velocity vector with the horizontal angle. So these 5 things are the 5 components that we are going to solve for. So to take this away. So first, let's draw a diagram. Drawing a diagram helps with visualizing the problem to be able to answer the questions more easily. So, here's a cliff. Which is 125 meters. At the top of the cliff, an object is shot from the top. Object. At an angle of 37 degrees. With an initial velocity of 105 meters per second. So when the projectile is released, it does not continue to go. Obviously, acceleration is acted on the object, so it eventually will go down. We are trying to solve for this distance, x, and all the other components from the problem. To start, it is helpful to set up all of the numbers given to you in the equation, in the x direction and y direction. X direction. Vix equals 105 cosine 37 degrees. We do this because from the problem, you are only given the initial speed. You need to find the velocity for the rest of the trip of the object. Acceleration in the x direction is 0. Time unknown. Delta x, which is here, also unknown. And final velocity of x, unknown as well. Next is the y direction. That'll look better. For the y, it is similar. VIY equals 105, but it's sine 37 degrees. Acceleration in the y direction is equal to negative 9.8 meters per second squared. Time is unknown. Delta y, negative 125, because the projectile is going from the top to the bottom, which is going at negative 125 meters. And the final velocity for y is unknown as well. So, here's everything we need to know to do the problem. Next, we are going to find the first part of the problem, which is time, taken by the projectile to hit the point P. Point P on this problem is at the very, very end where the object lands. A. First, you use the formula delta y equals VIY t plus half AY t squared. This is the formula to find delta y or any other component of the formula in the y direction. Delta y is negative 125. VIY is 63.2, which is 105 sine 37 degrees. T, because t is unknown, plus half negative 9.8 t squared. Working through the problem, you try to isolate t, which is time. Minus half times the negative 9.8 equals negative 4.9 t squared. For this problem, you're going to have to do Pythagorean theorem. First, you have to get everything to one side. Once you isolate t, you find out that t equals 14.6 seconds. Next, determine the range x of the projectile as measured from the base of the cliff. So here we're trying to find delta x. Similarly, it's a similar equation but in the x direction. Delta x equals VIXT plus half AXT squared. Next, you plug in the variables. Delta x is unknown, equals 83.9 times 14.6, which was from the previous problem, plus 0, because acceleration in the x direction is always 0. 83.9 is derived from 105 times cosine, or 105 cosine 37 degrees. To continue with the problem, you find out that delta x equals 1,227.099 meters. Moving on to C. To remind you, C is to find the horizontal components, horizontal and vertical components of its velocity. C. To set up the equation, you use v f x, which is the final velocity in the x direction, equals initial velocity in x direction plus ax t. You're trying to solve for this. So to get that, you plug in the other variables. V of x equals 83.9, which again is from 105 cosine 37 degrees plus 0, because acceleration in x direction equals 0. V of x equals 83.857 meters per second. Next, do it in the y direction. Similar formula. Vfy equals viy plus ayt. Similar, you plug in the variables. Vfy equals 63.2 plus negative 9.8 times 14.6. And again, 63.2 is derived from 105 sine 37 degrees. Get the answer of Vfy equals negative 80.216 meters per second. To put this together, it's helpful to put it in component form, which is Vf equals 83.857 x direction minus 80.216 y direction meters per second, which is the horizontal and vertical components of its velocity. Next, moving on, letter D, which is the magnitude of its velocity. To get that, you take the answers from part C, and you square each answer and find the square root. Part D. Formula is Vf equals square root of 83.857 squared plus negative 80.216 squared. By doing the formula, you get an answer of 116.05 meters per second to be the magnitude of its velocity. Lastly, you need to find the angle made by the velocity vector with the horizontal. To do this, it's simple. You use inverse tangent, which is theta equals tan inverse of VFY over VFX. Next, you have to plug in the variables. Theta equals inverse tangent 80.216 divided by 83.857. Here, you don't need to worry about the negatives because it'll work out in the end. To get the answer, you plug it into the equation, you get angle to be 43.729 degrees. And that's it. I hope this tutorial of how to solve a projectile motion problem helps you. Thank you.